Okay, let's look at the data types one by one. So the first data type we're going to look at are numbers. As you can imagine, there are different types of numbers: integers, floating point numbers, short as float, and real numbers, and also imaginary numbers. And in combination, those are the complex that we're looking at here. So if you want to define an integer, you can have my_int equals to 1, and then you can check out the type of that. Remember, we can always use the type function to get the type of a variable. It will tell you it's int, that's the type of an integer type. Okay, and you can use this, whatever returned by the type, you can use that to cast other types into this type. And I'll show you that later. And we can define a floating point number as 3.14, and we can get the type should be float. So that's the type we can use to cast my integer, which is 1 down here, into a floating point number. So it would tell you, return you with the 1.0. And we can also define a complex number by having the real part. And this can be integer, can be floating point number with imaginary part. Now pay attention here, because if you put, say in maths, we usually have I as the imaginary part, but if you do that here, it will tell you there's a syntax error because Python doesn't recognize what is this thing. And if you do a multiplication in between, it will tell you I is not defined because we haven't defined I yet. And what if we change into J? The same will happen because J is not a variable yet. There's no J. So if we do dir, you won't see J is being defined there. Okay, so J is not defined. So if you want to define an imaginary number, you need to have something J without the multiplication. And Python will pass this number or pass this text into an imaginary number. So if you do that, they would just basically tell you that's a value down there. So we can have C2 equals to this. And by the way, there's a method in a complex. You can find the conjugate, which means it will flip the sign of the imaginary part. In this case, it will become 1 minus 2j. So if you have C2 times the conjugate of itself, you can think of this as a vector. So this is the x value, this is the y value, and this would tell you like a x squared plus y squared, right? So it would tell you 5 is like the length of this, the length square of this vector. Another thing that I want to show you is that sometimes when we compare floating point numbers, say a equals to 3 point, say 10, okay, 100, and then a divided by 3 times 3. Okay, let's try another value. Okay, like this one. So in maths, this should be 11, and then a divided by 11 multiplied by 11 should be the same thing as a, right? But sometimes it's not, because computers store floating point numbers not exactly its true value. There would be at some point after, usually it's the 7th decimal places, um, the numbers after that is not trustworthy anymore. So you can't say this equal to a. It will tell you it's false, although mathematically this should be equal to a, okay? Which means you should not compare or use this double equal sign to compare floating point numbers. What you should do is to calculate how much differences are there. Let's say we store this one as b equal to this. Let's just verify b is that 100.0 something 1. And then the way we compare that is that we a minus b, and we get the absolute value of this, and check whether this is smaller than a tolerance. Say we have 1e minus 7 here. So 1e minus 7 is just the scientific notation of a floating point number. I didn't cover that here, but you can basically Google other format how you can define a floating point number. So this means that 0.00070 and then one of them. Actually, we can just show it here. Let's do a F string Titan F. Yeah, it's basically this value. Okay, it's like 1 times 10 to the power minus 7. So if we have 1e minus 7 times 1e 7, that should be 1. Anyway, we define a tolerance. You can set this as the tolerance because what we're trying to find out is that whether the differences between this A and B is within the tolerance. If it's within the tolerance, we will treat them as equal. Otherwise, we'll treat them as different. So this is how we should compare floating point numbers. So when we do that, we tell it's true, so you can treat A and B as the same value. And of course, this tolerance will depend on the memory of your computer. The larger memory, the more accurate this will be, which means you will have more decimal places that is trustworthy. So you can set this tolerance even smaller. But usually you can take up to the 7 decimal places as the rule of thumb. Okay, so here I have another example is that we can import math. So import just means you import someone else's code. So math comes with the built-in Python. It's already there. Someone has written some Python code and put it under the file called math or package called math. And then inside this math, there are some variables like math.py, which is just the value of pi, or the sine function, for example. It's just a function you can call. Sine 0 should be 0, like that. So when we say math.sine and math.py on that, which means is sine of the values of sine pi, it should be 0, but because of this truncation error of floating point numbers, it end up with a very small number, very close to 0. And we can basically verify this saying whether this one is 0, like that, and it will tell you it's true. So if you work with NumPy, now this is for non-beginners. If you work with NumPy, and NumPy will have some tools that tells you whether things are close to each other. So is close function, you can use that. So basically that's doing something like this. Okay, so that's about some of the basic operations of numbers. And then the other thing I want to show you is integer division. Sometimes when we do division, like 3 divided by 2, you should end up with 1.5. But in early versions of Python 2, they might end up with 1, because if both operands are integers, it might end up as the integer as the return value. And because it is an integer, it cannot represent 1.5, so it truncates to only the integer part, which is 1. In Python 3, you don't need to worry about that, but just be aware in Python 2, the behavior of the division is a little bit different. In Python 3, if you want to do integer division, there's an explicit way you can do it, which is double slash, and in this case, it will be 1. Okay, so if we say 7 divided by 3, it will be 2. Integer divided by 3 will be 2. And you can also check the modulo, which is the remainder after the division. In this case, it will be 1, which means 7 will be equal to 3 times 2 plus the remainder, which is 1. Yeah. Again, we can use dir on the module, so we import the math module. We can inspect what other people has written there, and you will see a bunch of functions and the natural number here, and some other functions. And also the isClose is here, so you can use this as well. The math module is also evolving. Sometimes it borrows from other packages. For example, if we want to look at one of the functions, we can use help as we demonstrated. And we want to look at that math.isClose. It will tell you determine whether two floating point numbers are close in value. And you can see there's a relative tolerance and also absolute tolerance. Okay, so you can set this tolerance. If you don't set it, you use this by default. If you set something, it will override this and use that in the calculation. And A and B are just the two values you want to compare. And you can use the square root in maths. There's a square root function there. It will give you the square root of a value. And because math doesn't work with complex numbers, and if you get the -1 inside the square root, it will tell you there's an error. So in order to work with complex numbers, you need to use the CMath, which stands for the complex math module. And if you do the -1 square root there, it will tell you it's the 1 times the imaginary unit, which is j here. By maths, we call it I. Okay, this is the numbers, and there are quite a lot here. What I want you to do is to do some exercise. I can just make up some exercise here. Okay, number 1 is calculate. So there's some noise in the background. It's just the Google Home saying cannot connect to Wi-Fi. Let's ignore it. Okay, let's calculate sine of maybe pi on 4. Okay, so use the math module to calculate that. And then second is to find a case of truncation error and use the ABS function to determine they are equal or they are within the tolerance of 1 times 10 to the power of -7. Okay, I made this one because I want you to just follow those syntax and write down how to express all these numbers and use ABS on that. Okay, and last one is imagine you have a total of that number. I just made it up. Patients, and you want to divide them into 11 groups for clinical studies. Find out how many groups or how many patients per group and how many reminders or like in the last group. Right. So what it means there is they want to divide this one into, sorry, and this is probably the wrong question. Divide them into groups and then let's say 11 patients per group, and then find out how many groups are there and how many reminders. Probably what is the reminder in the last group. Okay, you want to divide the number of patients into 11 groups and you want to calculate sorry, say that again. You want to divide the number of patients into a number of groups, and each group will have 11 patients, right? But as you can imagine, the last group might not have 11. It might have less than 11. So find out how many groups are there in total and how many patients are there in the last group. Okay, spend some time working on this. I'll see you in the next one.